Hi everybody, this is Kathy Driscoll with the Nature Foundation, and this is part 2 of matter. I'm hoping that you all filled out your observation sheet for the 3 experiments that we discussed in the first part, and that was to understand the matter, that it would be solid, liquid, and then gas. So we'll go over the results and see what you guys may have come up with, and we'll see how I do with this experiment myself. So as you know, that matter takes on different forms. So our very first experiment, we were to learn about 3 different objects, and that is that we are going to investigate something that you could potentially poke like your pen or pencil through. So here I have like a golf ball, and I'm trying to poke my pen through that, and that's not going to happen. I have a toy horse. No, not even going through the mouth, nothing. And then a coin. So also I wanted you to just feel the 3 different pieces that come with each kit of their matter, and that is, this is the coin, the golf ball, and the horse. And I wanted you to write down what you thought they felt like. Did they feel like that you could squish them? Did you feel like that you could manipulate them in some way? And if you found that you couldn't, I wanted you to write down that these guys were just solid as a rock. So in short, for your experiment number 1, your answer would be, what form are these objects in? And hopefully you had underlined or circled solid. And then, that's experiment number 1. Experiment number 2, we had to do a little bit more work and measuring on top. So yes, I am actually working out of my kitchen at home, and guess what? A kitchen is just like a chemistry lab, because you are going to need things when you're cooking and baking to use to measure so that your food would turn out correctly. So chemistry and cooking are very, very much alike and very practical to know. So here's my lab. Everything that I have brought to the schools, I brought from this kitchen, practiced in this kitchen, and I haven't blown, well, not a whole lot up. I haven't blown a whole lot up. So this is a great place to really experiment, because it can get messy and you have everything you need here to clean up. So experiment number 2 required you to take 2 liquid-like matter, soap, and water, and I had you measure it out. So hopefully you have your sheet and you'll say, oh yeah, Miss Kathy said to measure out 1/4 cup of water, and then look at it and think, even put your finger in there and feel it. Actually, my water's warm. I apparently just did the dishes. So this water, 1/4 cup, is warm, but I can definitely put my finger through it. So this matter is different than a solid, okay? And then the soap, we can see it moving around in the container. So we know that it's definitely got some mobility, unlike a solid matter. And in the instructions, I said to go ahead and take a Ziploc baggie, which of course I moved. Voila. And to measure 1/4 cup of that water. Okay, and this is after you write down what you felt. I wanted you to write down what these 2 different phases of matter, or what these 2 different types of matter felt like to you. And then you pour the cup of water in there, as I'm doing. And then I wanted you to measure out 1/4 of a teaspoon, which is, this is a tablespoon, teaspoon, half, 1/4 of a teaspoon of soap. And I'm using a colored soap because you can definitely see 2 different types of liquidy phases of matter that are different in their color, so to make it easier for us to see the experiment. Okay, Okay, and then I poured that in there. You're supposed to seal the bag. Everything you can find in a kitchen. Seal your baggie and then knead it. And then write down what it feels like here. And it feels kind of squishy. Okay, I'm seeing some bubbles, so I think I'm still feeling liquid, but those bubbles tell me that putting the two together, this very viscous liquid, okay, this leaves a residue in your hand, okay, whereas the water is just stuck my finger in there and it was dry. You put them together, that changed the composition of this form of matter. So yes, it is still liquid, but if you really thought about it, it did create some type of gas. So together it bubbled up. Those bubbles represent a gas. So I would have put, if I really thought about it, not just liquid, which was the perfect answer, but gas as well. So that was experiment number 2. Experiment number 3 is always everybody's favorite, because then we are going to take a solid, in this case, we're taking baking soda, and I wrote down the chemical compound of it. So in the first part of this lecture, we talked about the periodic table and all of the elements that make up matter on Earth and, well, the whole universe actually. So for us, this baking soda is a compound that's made of sodium. So hopefully you will remember this. Sodium, the symbol is Na, okay? And then there's a hydrogen involved, and then a carbon, which is C, and then an oxygen, but you needed 3 oxygen atoms here, so it's like carbonated. So it's sodium bicarbonate is what that really is. If you looked at the ingredients to baking soda, it will say sodium bicarbonate. So this is the solid that we're going to measure out. And then we are going to measure out some liquid, and this of course is just plain white vinegar. Okay, and so vinegar is acetic acid, and that means that it has, if you've talked about pHs at all, like the how basic or how acidic water can be or liquids can be, vinegar is very acidic, and you know this. Just think about the common denominator for some of these things. Things that are acidic, you can taste that it's kind of acidy. So, but white vinegar is not really nearly as acidic as other types of vinegar. So acetic acid's compound. So we're going to add sodium bicarbonate. So when I say add, I mean plus our vinegar, which is HC, 2 carbons, a couple of more hydrogens there, and an O2. It's almost like a sugar compound, okay? So it's sodium bicarbonate plus vinegar. And what is that going to yield us, okay? So this is like math, only in chemistry, instead of say equal, they say yield with an arrow, because we are going to rearrange all of these molecules when we add them. So how do we do that? So I had you guys measure out 1/4 cup of the vinegar. Hopefully you did this correctly if you read the instructions correctly. And you're supposed to put like 1/2 teaspoon of the baking soda in a balloon. Okay, so the vinegar is in the bottle. The dry matter, okay, is in the balloon. And then I said carefully put the tip of the balloon over the bottle, just like that. Okay, and then I wanted you to very carefully bring the balloon up and to pour its content into the liquid, and pay attention to what happens here. All right, very good. So you see that my balloon has now filled up with air, or what we would call gas. And unfortunately, just as I did that, I had a little tear. So hopefully that didn't happen to you. So two things are happening here. The question is that I asked you, is this going to be a gas or a solid or a liquid? So technically our gas is here and it is a liquid here. There's some gas in the bottle itself, okay? But the liquid has actually changed. It's no longer the vinegar compound. It's actually rearranged with the sodium bicarbonate to make a brand new liquid. So it yielded, here's our sodium to 2 carbons to 3 hydrogens and 2 oxygens is our liquid, which is sodium. This is what we call it, the common name, acetate. Plus, there is water in with that. So you could actually yield that water out if you wanted to. And then what happened to the balloon became H2O. Oops, sorry. Carbon dioxide. So when we actually breathe in air, we're breathing in oxygen, right? When we expel air after it all has gone through our lungs and through our body, the molecules have rearranged, and when we stop, when we breathe out like that, we're breathing out carbon dioxide, okay? So here is carbon dioxide being expelled in the balloon. That's the balloon. In the bottle, you have sodium acetate and water. So if you look at these letters and the numbers, they're still going to be the same numbers as you would here. We just rearranged all of these molecules. So, for example, here's 1 sodium, 1 sodium. All right, here's 2 carbons, and 1 carbon, 2 carbons and 1 carbon. Here's 1 carbon, 2 carbons. That equals 3 that were here, 3 carbons were here. Okay, so the numbers of these elements don't change, they're just rearranged. Same thing with the hydrogen. Hydrogen, there's 3 hydrogen here, plus 2 hydrogen, that's 5 hydrogens in this compound. Here in the sodium bicarbonate, there's 1, 2, 3 here, which equals 5 hydrogens again. Same thing with the oxygen. We've never ever lost anything. They just got rearranged, okay? Hopefully you figured out that it was gas, but this is what chemically is going on. There's a lot of really neat kitchen science chemical activities that you could do. And the next one you're going to get a kick out of, because we talked about 3 forms of matter. There's a 4th one. Okay, here we are to learn about another phase of matter. So we went over the solid, the liquid, and the gas. So what is this mysterious 4th phase of matter? Well, before we get into that, I would like to share with you some similarities to a chemical lab and a kitchen. Some of the typical equipment that's needed in both a chemistry lab and a kitchen require measuring. So your measuring utensils are very important, particularly in chemistry, because you're using the different phases of matter like solid and liquid. So generally you're going to be using things like this. This is a measuring cup in a household. But I mentioned my beaker before. A beaker is a very typical utensil in a chemistry lab, so they can measure liquids, and this glass is so sturdy and strong that it can take high temperatures. So you can stick it on top of a fire to boil things too. So beakers are a very important tool in a lab. Then we have our graduated cylinder that we use to measure the liquid more precisely. So, and I mean, especially with baking more than cooking, you want to make sure that your measurements are precise. Baking is more like chemistry than cooking. Trust me, if you put too much salt in cookies, you'll taste it, okay? So you have a measuring cup. That's a cup. This is a half of a cup. There's a third of a cup and a quarter of a cup that usually is a set in a kitchen. You got your measuring spoons to measure out liquids and solids accurately. And then other things that in a kitchen, I find this pretty good to mixing two different types of matter, like solid and liquid, is a whisk. So if you're making pancakes, something that is, flour-like and adding a liquid to is important to get that consistency. Some people call that a roux. Go home and tell your parents that. I learned what roux meant. It meant a liquid and a solid mixed together. Then in a lab, you use things like pipettes to be able to measure, like you would with a measuring spoon, like a teaspoon or a tablespoon. So again, the similarities are very significant in a kitchen and a chemistry lab. So our last phase of matter, this is why it's important to know the measurements, because it won't work if you don't measure this accurately. So it has been discovered a type of matter that becomes sort of liquidy and solid at the same time. It is called a non-Newtonian liquid. If you think about your historical scientists, think about Newton. He was the one where I had the apple a little while ago that fell on his head and he figured out gravity. Well, he figured out a lot of things. And one was that there is a form of matter where it can either be liquid or solid depending on stress. So here we have something that sort of looks like liquid and sort of looks like solid. And in the classroom, I would be passing this around to you and you would be holding it and going, wow, this is really cool, as we have done for years and years. And you may notice that it's starting to, show powder on my hands, almost like baby powder. And if I keep holding it and stressing it, it turns it more into solid. But if I let it go, bloop, you can see the liquid sort of changing here, just like in the container. So we call this Ooblech from Dr. Seuss, who is another genius. Or I like to call it other things. Notice I actually have it green because it's great to actually have around it, Halloween and stuff. But Ooblech or goop or gack or slime, but it is really a lot like our liquid crystals on our TVs. It's not really a solid and it's not really a liquid. So it's a non-Newtonian phase of matter that is just in between the two. So how did I do this? Because I know you guys want to know the ingredients to this. If you let it go, after a while it becomes very dry. So generally when you store it, you want to store it in an airtight container. Okay, think about the molecules of air. What could that do to dry it out? Okay. Also, you don't want to pour this down the sink because it can solidify and it can also clog the drain. And if you're using your kitchen as a science lab, I'm guarantee your mom and dad will love you, or whoever you're hanging with will love you if you clean up afterwards, because this type of science can get messy. So what is it? It is cornstarch, and I used green food coloring. You don't have to. And just simply water. So it is a 2-to-1 ratio, and I'll have the ingredients at the end of this, but it is 2 cups of cornstarch to 1 cup of water. So you're going to put your cornstarch in a container, so 2 cups of cornstarch, and then 1 cup of water, carefully pour it in. And I like to use the whisk because that seems to make it less lumpy. And so you're whisking it just like you're going to do pancake batter. And you slowly add the water, okay? And again, be very accurate. Your cup has to come, your water and your powder has to be right to the top, okay, when you pour it in. And then if you want to add food coloring like I did, thanks for Halloween, you can add that to it. And that is the ingredients to Ooblech, your 4th phase of matter. So if you guys decide to do this on your own, please do share with us through your teacher. I would love to see how you get your 4th phase of matter. Good luck.